What if the air had more oxygen? A curious nova journey into the future. Take a breath. Right now, about 1 in every 5 molecules you just pulled in was oxygen. 21%. That number has barely moved in hundreds of millions of years, and almost nobody ever thinks about it. So here is a tempting idea. Oxygen is the gas of life. We run on it. So wouldn't more of it be better? A world with richer air, where you breathe easier, heal faster, feel more alive. It's one of the most reasonable-sounding guesses you can make, and it is almost completely wrong. Because if you turned up the oxygen, the first thing you would notice is not easier breathing. It's that the world would start to catch fire. Let me show you why by slowly turning the dial up. 21% today, then 25, then 30 to 35, which the Earth has actually reached before, and finally a wild 50%. But first, one myth we have to clear away because it changes everything. People say more oxygen just means easier breathing. It doesn't. What your body actually cares about is not the percentage of oxygen, it's the pressure of it, the force pushing it across your lungs into your blood. That's why you can suffocate on a high mountain where the air is still 21% oxygen, just at lower pressure. And it's why a scuba diver breathing ordinary air deep underwater can be poisoned by it, because the pressure forces in too much. Hold on to that idea. Oxygen is about pressure, and at the wrong pressure, it turns on you. Now the fire. Fire needs 3 things: fuel, a spark, and oxygen. And oxygen is the aggressive one, the gas that rips other molecules apart. Scientists found the floor for fire decades ago. Below about 15 to 17% oxygen, nothing will burn. Not dry paper, not dry wood. The flame just dies. We live at 21% comfortably above that line. Push higher and flammability doesn't creep up. It scales up fast. For a long time, scientists believed in something called the fire window. The idea was that somewhere around 25 to 35% oxygen, you hit a hard ceiling for life itself. Above it, even damp plants would burn, and a single bolt of lightning could set off firestorms that swept whole continents and never let the forests grow back. The newest supercomputer models from researchers like Claire Belcher and Andrew Watson soften that picture, and it's a fascinating save. It turns out moisture is a stubborn shield. In the wettest tropics and the soggy far north, the sheer water in the plants still soaks up enough heat that even oxygen-soaked forests survive. The whole planet would not go up in one blaze. But don't get comfortable. Everywhere drier than that, the world would transform. Wildfires would become routine, vast, and ferocious. By the time you reach the low 30s, models suggest the Earth could lose nearly half of all its forests, and the raw physics is brutal. In the lab, when you raise oxygen from 21% to 35%, the time it takes a material to burst into flame drops from about 75 seconds to just 16. At 50% oxygen, even living, green, juicy vegetation would flash into flame. A campfire would behave like an explosion. And we know exactly how dangerous a rich oxygen world is, because we built one by accident and people died in it. In 1967, 3 astronauts sat inside the Apollo 1 capsule during a routine ground test. To save weight, the cabin was filled with pure oxygen. And in that air, ordinary things, the nylon of their suits, the plastic on the wires, the Velcro on the walls, stopped being ordinary. They became fuel waiting to go off. One tiny electrical spark, and the fire tore through the sealed cabin in around 25 seconds. Materials that are perfectly safe in the air around you right now turned violent, just because there was too much oxygen. That is the danger we are talking about, scaled up to a whole planet. So fire is the first answer. Now for the one you were probably waiting for, the giant bugs. You have seen the pictures. The Carboniferous, 300 million years ago, when the air really did hit 30 to 35% oxygen, and the world crawled with monsters. dragonfly relatives with wings as wide as a hawk, a full 70 centimeters across, and Arthroplura, a millipede the length of a car, over 2.5 meters long, 50 kilograms, the biggest bug that ever lived. So if we pump the oxygen back up, the giants return, right? Here is where the textbooks were wrong and the truth is better. For decades the story was simple. Insects don't have lungs. They breathe through tiny tubes that let air seep directly into their flesh. And the thinking was that in our thin 21% air, oxygen just can't soak deep enough into a big body, so a giant insect would suffocate from the inside. More oxygen, the story went, soaks deeper, so giants become possible. But brand new studies scanning the actual breathing tubes inside insect muscle blew that apart. Those tubes take up less than 1% of the muscle. There was always plenty of room to add more of them. If oxygen were really the wall, evolution could have knocked it down any time. And when scientists raised modern insects in high oxygen tanks, they grew only a little bigger. No monsters. So oxygen was never the lock on the cage. What was? Mostly the absence of anything that ate them. In the Carboniferous, birds and bats simply did not exist yet. Nothing hunted a slow, hawk-sized dragonfly out of the sky. The air was also denser, which made it a little easier for a heavy insect to fly. They grew huge because they could, in a lush, predator-free world. So if you raised the oxygen tomorrow, you would not wake up to giant insects. The hawks and the sparrows would eat any bug that dared to get big, long before evolution could ever rebuild a monster. The giants needed an empty world, not just a rich atmosphere. Now let's talk about you, because here is the hardest twist. The gas of life is also a poison. Doctors actually use pure, high-pressure oxygen as medicine in sealed chambers to heal stubborn wounds and rescue divers. For a short, controlled dose, it's powerful. But push the pressure or the time too far, and oxygen turns on the body with frightening speed. At high enough pressure, it attacks the nervous system directly, with no real warning, ending in sudden, violent convulsions, a full seizure. Milder but longer exposure, the kind a 50% atmosphere would give you all day, every day, goes after the lungs instead, slowly burning away their delicate lining until they fill with fluid. The very thing keeping you alive would start dissolving you from within. And even a gentle bump, say 25% for a whole lifetime, would quietly age you faster. Back in the 1950s, a scientist named Denham Harmon proposed that aging itself is partly oxygen damage. Every time your cells burn oxygen for energy, a small fraction leaks out as unstable, hungry molecules called free radicals, and they tear electrons out of whatever they touch, your cell walls, even your DNA. Your body fights them off constantly. Flood the air with more oxygen and you overwhelm those defenses. More damage, faster aging, more cancer. A richer atmosphere wouldn't make you feel more alive. Over a lifetime, it would wear you out. And it wouldn't stop at animals. It would starve the plants, which is maybe the strangest result of all. Almost every crop you eat, wheat, rice, soybeans, runs photosynthesis using one critical enzyme. And that enzyme has a famous flaw. It is supposed to grab carbon dioxide from the air, but it is clumsy, and it grabs oxygen by mistake a fair amount of the time. When it does, the plant wastes precious energy cleaning up the error instead of making food. Now flood the sky with oxygen. That enzyme starts grabbing the wrong molecule constantly. The plant chokes on it. Models suggest staple crop yields could collapse by 20, 30, even 50%. A world with more oxygen would not be greener and lusher. It would be a world of failing harvests and global famine, where the air itself is strangling the food supply. So let's add it all up. Turn the oxygen up and you don't get a paradise. You get burning forests, dissolving lungs, faster aging, and crops that starve in rich air. Which leaves one last question, the deepest one. If high oxygen is this catastrophic, why has the Earth sat so calmly at 21% for so long? What's holding the dial in place? place? The answer is that the planet has a kind of automatic kill switch, and it is beautifully grim. Oxygen does drift up and down over deep time. It hit those 35% peaks. It sank near 15% in other ages. But every time it climbs too high, the same thing happens. Wildfires explode across the drier world, and photorespiration strangles the plants in the wetter world. And together they wipe out a staggering share of all plant life on Earth, perhaps 86% of the world's living biomass at 35% oxygen. And here is the loop that closes it. Plants are what make the oxygen. Burn and starve the forests, and you kill the source. You also cut off the nutrients washing into the oceans, so the ocean's oxygen, making life, dies back too. The oxygen supply collapses, and slowly, the air drifts back down toward 21%. Read that again, because it's chilling. The Earth keeps its air breathable by being willing to torch its own biosphere to do it. 21% isn't a lucky accident. It's the number the planet violently defends by sacrificing life whenever the balance tips too far. So the next time you take a breath and feel nothing at all, remember what that nothing actually is. It is a knife edge held perfectly still. Just a few percent lower and fire would die out entirely. A few percent higher and the world would burn. You are not breathing ordinary air. You are breathing the single most fiercely balanced number on the whole planet, and you never even feel it. This has been Curious Nova, curiosity across time. I'll see you on the next one.